All right, here we go. Centers and spread, page 2. So pretty much we've talked about the centers and the basic shape. Spread, there's a couple different things to talk about. There's range, which most people have heard of before. There's variance, which not everybody's heard of before. And standard deviation, which most people have heard of before. There are two types of variance and standard deviation, though. There's one that's used for a sample, where we divide by n minus 1, and there's one that's used for an entire population where we divide by n. For some reason, we're not going to go through the proof. It's a big calculus proof, so we don't know how to do that yet. When you're dealing with a sample, the n minus 1 gives you a better estimate of the true variance and standard deviation. So if you decide to take statistics in college, you may actually prove that and see why, but we're not going to worry about that. We're just going to use it. Okay, so range, you should know from not elementary school, sorry, junior high, is just the biggest number minus the smallest number. All right, so the other formula is a little more complex. Sample variance, we use s squared. Sigma, this is the Greek letter sigma, and it means sum. It's the sum of x minus x bar squared divided by n minus 1. X represents each of the individual data points. X bar is the mean. N is how many numbers you have. So if there's 10 numbers in your data set, you'd have 10 minus 1. Standard deviation, once you've figured out this, is easy. It's just the square root of that whole thing. Population variance is the same, except that we're dividing by n instead of n minus 1, and so we use the Greek letter sigma to represent the standard deviation and variance for the population. So this would be sigma squared. And yes, it is another sigma. This is the lowercase sigma. This is the uppercase sigma. So standard deviation is just the square root of that whole thing. All right, so example 2, we're going to do this by hand, all of it by hand. So we have different number of calories in 6 different light beverages. Okay, so first thing I'm going to do is put these in order, 28 through 33. So range, maximum minus minimum is 5. Mean, add them all up, divide by 6. The mean average is 30.67 calories per 100 milliliters. Okay, so sample variance. I take each of these numbers individually. Take the number, subtract the mean, square it. Plus, take the next number, subtract the mean, square it. Plus, take the next number all the way to the last 33. So 33, and there would be 2 of these because there are 2 33s, so there would be 2 of those. And then divide by 6 minus 1, and we get 4.27 is our sample variance. For IB students, this is the number that IB tends to use most of the time. For everybody else, we usually focus on the standard deviation, which if you remember is just take the square root. So it's just the square root of 4.27 and we get 2.07. Okay. All right, so example 3, we put these numbers into a calculator. And I'll make a separate little video showing you how to use a TI-8384 calculator, or you can go online and just find a statistical calculator online. So that's up to you how you want to do that. Or I think even right now the TIs are offering a free online calculator during this time right now, I'm pretty sure, so I'll look into that for you guys. It doesn't do all of it for you, though. It doesn't do the range, it doesn't do the sample variance or the population variance. So the calculators will usually give you the mean. So if I plug all these numbers in and tell it to do the statistics, it gives me the mean is 28.75. The sample standard deviation is 6.12. The population standard deviation is 5.86. So the other 3 you have to do, well, this one, all you have to do is find the biggest number was 39, the smallest number was 19, so the range is 20. To get the variance, all you have to do is take the standard deviation and square it. So 6.12 squared is 37.45. 5.86 squared is 34.39. All right, and again, I will make a little video on how to do that, and definitely, show up for office hours and I can show you how to do those. If you have a TI calculator, I can show you how to do it on the calculator. Otherwise, I'll see if I can recommend a good computer one that you can look up and use. All right, so that finishes page 2. Thanks.